This is PT Thrifty, the lowest cost timecode device there is. Or rather, this is PT Thrifty. The Rev2 boards have arrived, and in this video I'm going to attempt to solder them up and see if they work. Here I've had the boards assembled by a contract manufacturer, and they're missing just a few parts which I'll solder on. Firstly, we have some buttons to make them function. A connector so you can plug the audio cable in. Some standoffs so that you can mount them to the board. The Raspberry Pi ports. And some crystals to make the Raspberry Pi boards work more accurately. So it's going to be a bit of an afternoon. Prior to assembling the boards, I've taken the time and I've flashed the code onto the microprocessor. This has the advantage that when it's powered up, it will blink its LED. There we go. This at least gives you confidence that the code is running on the platform. When we remove the crystal and place it with a new one, we want to make sure that it functions before we start soldering it to the PT Thrifty board. Up close, this is what the PCB looks like. The contract manufacturer assembled some of the surface mount components for me, but notably we're missing the button to signal the UI and the connector that goes to the other device to upload or download the LTC signal. This is what the Pico board looks like. On the other side, we have the crystal and some components around it. We're going to remove the crystal and R8 on this side. And after we've done that, we're going to replace the crystal with a TCXO, a more accurate temperature compensated crystal. This is the easier part of the activities today, soldering on the connector and the switch to the PT Thrifty board. I didn't have these assembled in China, basically because through-hole devices cost more, and also the connector has some of the options have an extra pin on the rear of the connector for the tip switch, which isn't required for PT Thrifty, and this interferes with the other componentry. So I have some of these here. Simply snip off the extra bit, and we're going to locate the mounting pins on the board, and then literally just solder dab the connectors so they actually make contact. Crap, we're going to need a little bit more solder on that. This is going to be an interesting video because I've not done this sort of thing before on camera, and we'll see how it all goes. Apply some extra solder. So there's little mounting pins on the underside. Those register into the PCB. And we can then see the connections. It's also worth pointing out that these connectors are TRRS. The second ring is not used for signaling, it's used for the board to detect the presence of the connector. So when you're connecting to PT Thrifty, use a TRS cable, not a TRRS cable. This is the more difficult part of the operation. We're going to remove the crystal. What I found is you can apply some solder to the top of the can, and that will help transfer heat into the component to lift it from its surface mount pads. And we also want to remove R8, which is the center component on the left hand side of the crystal footprint. We're going to apply a little bit of cleanup so the pads are clear from residue solder. So just use a little bit of solder wick to achieve that. And then apply a little bit of solder to pads 2 and 3, which are the two on the left hand side where the new crystal will be placed. The trick in this part is standing the crystal up on its end, so pins 2 and 3 are connected and pins 1 and 4 are floating in mid-air. And as things are difficult to hold on to, it's easiest with a second pair of tweezers I found. So the crystal itself has a little circle on it indicating pin 1. That's the pin we want in the air. We're going to hold the crystal vertically, or the TCXO vertically. Just apply some heat to the solder that's on the pads, and that will solder pins 2 and 3. And then we're going to connect pin 1 to the insides of the 2 caps on the lower right hand side. Those caps are C19 and C17. This will carry the 3v3 to power the TCXO module. The easiest way I found to do this so far is just to add a small piece of zip wire, strip back the insulation, leaving I guess about 1 millimeter, and that can be soldered across the ends of the caps. This has the side effect of making pin 1 on the board connect to the 3v3 supply, and you can buzz that out with a meter. So adding the wire between C19 and C17 has the side effect of making pad 1 on the crystal footprint 3v3. 3v3 is on the third pin from the top on the right side. You can just buzz to the wire and also to the pad and confirm that you've made a good connection. We're going to snake the wire up to pin 1 on the TCXO module. Again, we can buzz that with a DVM to check. And I guess at this point we can also take external power into the module and see whether the LED still flashes. So the fact that it still flashes means that the crystal is running and the code is running. I'll give you a close-up of this view now. So this definitely is not the neatest solder job, but that's basically what we're trying to achieve. A crystal on its side with power going to pin 1 from those two capacitors. What I'm going to do now is put a row of headers in this back row and then apply some hot melt glue so that the crystal and the wire are held in place. We don't need to worry too much about the hot melt glue changing the capacitance because the module is a lot more robust than a passive crystal. So I'll do that off camera and I'll give you a shot in a moment. So I've actually found when I'm doing this, I'm using an old display that's actually broken just to hold the pins in place, and then I'm just going to solder this rear row, the one that bridges between the two sides. And the reason I'm doing that is that this will give somewhere for the hot melt glue to bond up against, and we can then sort of again do a test to make sure everything works with the power before buttoning the whole thing up. So hot melt glue, this is always messy, so just apply enough to cover the module and hold the wire in place. And up close, that looks even worse than it did before, but kind of hides a little bit of the wiring mess, so perhaps that's not too bad. And for the side ones, I've got these slightly deeper pin headers, which should help prevent the two boards squashing together so much. I'm going to use those to mount in here. I should follow my own advice. So again, just doing a little check, so we're powered. Type C, LED still flashes, good sign. Let's put these headers on the sides. Oh, and if it wasn't clear, the crystal side is the side of this board that goes towards the PT Thrifty board, so it's sandwiched in between the two boards, and this other side is the exposed side with the buttons and the LED. So once we've got the headers in place, we can take our PT Thrifty boards and break out the mouse bites, or break out the boards from the mouse bites, where the manufacturer has panelized the small boards into pairs in this case. And we're going to put two boards together. So back row in, and then just solder around the edges. So as you saw from the close-up, the Rev2 board has a second set of headers on either side. That's really for the DIYers among us who want to do some more interesting stuff with this board. That exposes SPI, I2C, UART and GPIO pins for utilizing this board in other projects you potentially can add all sorts of interesting devices around. So I'll leave that for people to have fun with. So I'm just doing the corner pins, and then I'll run down each row. If it wasn't running away from me. In your cage. Best angle soldering here. Okay, and we're missing the buttons. Can be mounted from the reverse side of the board so that it's nice and out of the way. Fits in there. And the moment of truth, well, not quite truth, this is what it looks like. And this is the moment of truth, powered up with the whole thing attached. We get the single blink when we so the moment of truth, we have a single blink when it powers up. Push and hold, put it into jam mode, select orange, okay, that is bizarre. The sequence of LEDs is different. Interesting. I guess that's a to be continued, because that's not what it's supposed to do. So looks like I've got some investigations to do. So I think I understand what's going wrong. I checked by plugging the board into Phony and looking at the config file and the libs directory. That's where it stores which FPS it's going to operate at and whether it's drop frame, etc., etc., etc. It seems that the boards I ordered from Amazon, the RP2040 boards, have a different wiring for the NeoPixel in which primary channel is which RGB is which RGB. So if it's set to 29950, which is 97 drop frame, which is what I'm currently filming at, it flashes green or slightly off green. If I push and hold, I'm getting flustered. Wait for it to boot. Push and hold, goes to solid color. Connect my recorder and it syncs, goes to white. And if we look on the other side, we can also see the 1 pps LED flash. So here's a close-up of the two boards. On the one with the actual cable plugged into it, we have this board which has a Victor 183 next to the NeoPixel, and this board, which is an official Waveshare board, has the Waveshare logo. So apparently, depending on which board you use, you'll get different colors. We'll see if we can figure that one out, and I'll advise. But anyway, it seems that the board itself is functioning. It's synchronizing to LTC, and basically an assumption is that it's also outputting it too. I'm not going to test that right now because I'll desynchronize all my other devices if I do that. So that's how you put a board together. The only other thing you might want to do is a little piece of heat shrink around the outside of it to protect the terminals. If you're going to use the expansion ports, let's call them, on the side, you probably don't want to do that. You can fly wire your other devices. I've got a whole heap of things that are interested in my tray. I'll just give you a sneak peek of what I've been up to. Doesn't really take much imagination to realize what that will be. Anyway, that's it. PT Thrifty Rev2 is alive. Yay!